Hi, welcome. This is Shudipto and I would like to explain you today the usage of async and await keywords in C#. Now the prerequisite is that you must be little bit familiar with threading concepts in C# or in any previous programming language, and also you must have some understanding of delegates in C#. Okay, so these are the two prerequisites. If you don't understand them, you can still don't worry and watch this video. You'll understand some extent why exactly this async and await keyword is used in the modern programming area. So let's get into Visual Studio and let's create a new project. Let's name the project as Async Await Demo, and we are creating this project for Windows Forms application for a very specific reason. So let's create an Async Await Demo project inside Windows Forms app and click OK. This has created our application, and now before I really go for the explanation of the program constructs, let me first explain you how exactly async and await keywords are used and why they are used. Well, in modern programming you will find these kind of things quite often than not. You will find very often that okay, when there is a function, so for example, even if a button click function, void some function, maybe some method or some function, and you'll find that this function has been marked with async. Okay, and there are some lines of code over there, some lines of code, and all of a sudden you can find an await keyword and then some line of code over there. Okay, so this is the common look of async and await. Okay, so what does this mean? Having a function being marked as an async and then writing some bits of code, some functions, maybe these are some functions or maybe some variables being used, some loopings, whatever, they are like programming codes, and then all of a sudden you find an await keyword, and then after that you still have a lot of functions coming after that. Okay, so this is a general structure of async and await, though you can have multiple awaits. Okay, you can have multiple awaits, you can have an await again, but if you have at least an await, you must be marking the function as async. Once again I repeat, if you find at least one await keyword inside a function, inside that function, then you must mark the function as async. Okay, so this is the structure. Now I would like to explain you now what is the exact purpose of this. The most important purpose of async keyword is to instruct. See, when you create a function, that means this function is being called from someone, right? If we have a function, most likely that we are calling the function from some place. So whoever is the caller, the function, knows one thing, that this function will be returning to the caller independently of whether there is a task getting end inside the function or not. Once again, let me repeat it what I just say you. Marking a function as an async means whoever is calling will know this function may return prematurely even before it completes its execution. So execution might continue in the background while the function may return back to it. This is something marked as by writing async. Now when I say return back, I mean returning back to the caller thread. Yes, returning back to the caller thread. If all this thing don't has any meaning to you, you'll get meaning the very moment I show something using this button click. Okay, you can find this as button click. Let us do one small thing. Let's write this button as do a long task. Okay, so that means whenever I'm going to click this button, there will be a long task that will be spawned, that will be started. So here what I do is that let's add a function void long task, long function. I just say long, my long work, my long function. Okay, like this. Okay, so that function will be doing a very long task, and after that this function, well, may return some value as well. It can return some value as well. Okay, so this function will be doing a long task, and after its successful execution it is going to return some value to the caller. So as of now we don't know how long this function will work or how to make this function work for long until and unless we have a loop running from 1 to 1 million or 1 billion. Instead of doing that, let us do one thing. Let us try to sleep this function for about 2000 milliseconds, which is 2 seconds of time. So this is a long function, and I'll try to make it go to sleep for 2000 milliseconds of time. So here is what we do: system.threading.thread.sleep for, okay, let's make it sleep for 3000 milliseconds. So it goes to sleeping for 3 seconds. After that, it is going to do some sort of calculation and return the value of the calculation. We are once again going to take advantage of random number, random object in .NET equals to new random. We just want to be creating a random number, anything between 1 to 10, and return that value to the caller. So I'll just say int number equals to random dot next. You have anything between 1 to 10, not including 10. It will be giving you any value between 1 to 9 actually. It just excludes the last value, the random number generator. Okay, so after that we will just be returning that num to the caller. So it's pretty very simple function, no complications. This is a long function, and this long function is waiting on its own thread for 3000 milliseconds. After that, it is creating a random number generator. It is asking it to give it any random number between 1 to 10, getting inside num and returning subsequently that number back to the caller. This is the caller code. So let's call this function. I'll just say integer number equals to my long function, and after this we will just have that message getting printed in a label. So here is the label for me. Okay, label 1. So once I get this, I'll just write label1.text equals to number dot toString. All right, and you also want to do one thing, that the very moment you call this function, after that I just want to have a message that please wait, it is processing the task. So level 1 text will write like, we'll do this code before it. Just write please wait. Okay, this is fine. Let me tell you, this is something that is very stereotype. We have been doing this for quite a long time. So it's very easy. So the moment you click this button, it flashes a message on the label, please wait. You call a long function, and then after the function is done with its work, you are basically calling its toString to get the response and setting it inside the labels text. So let's run it. My antivirus is trying to detect any virus within this program, so I need to be stopping this antivirus for a while at this time of demonstration. Let it scan first, let it start automatically, but I would like to stop this antivirus for a moment. So here's my antivirus, disable for 1 hour of time. Fine, good. I just made my antivirus to sleep. Okay, so this is a long task. I like to click on this and you see what happens. The very first thing you notice that please wait, that stuff did not come in. Okay, even if you clicked on it, even if that was the first message to be flashed inside the label, but you did not see that. And after 3 seconds of time, you directly came up with the result. Wait. Now, let me tell you what exactly happened with this waiting. Let me do it once again. Click, you wait, then you get it. At this time of waiting, you even cannot move and drag your window, you cannot maximize, you cannot minimize. Even if you have some other buttons, you cannot go and click them either. Okay, so for example, you have got some other buttons doing some other task, so even you cannot click them. The application is totally freezed during this waiting, so you just have to wait and nothing else. That means the main thread that really started this function call is now totally busy in doing something serious, and you are not getting access to your UI even. This last line is very important. What I said is telling that this application's main thread is busy in getting you inside this button click. So when you click on this, application main thread has been tied up with this button click. Please understand this fundamental point. Application's main thread has been totally tied with this buttons click functionality event. So this is not a good idea. Now how do I get around it? So the main point is you should not let the main thread to actually tie something with it. So what the main point is that I must write it, main thread or the caller thread must not be tied with a long task. You get me? Wonderful, if you have got me. So the main thread should be free just after it has made the call. So let it make the call and then let that be free so that the UI becomes responsive. You can go dragging it, you can shift the window, you can type it in another text box. Well, that is what we mean. Say for example, we have got another text box here. We will get a text box. Let's switch to common controls. It's easy to find something within common control section. Let's have a text box, fine. And let's run it. You'll find that even the cursor won't come blinking. I've clicked on it, okay? I'm clicking. Cursor has come only when the thing has processed, not before. So that means this application is totally not responsive, unresponsive, totally unresponsive at the time of its long task getting processed. Why don't we send this long task in background? Let that be happening in background while the application's main thread will be free to take all the user responses, user inputs. Do you get the point? It's very simple. Well, how to do that? The very first thing to do that will be to tell my application, hey, this button click is something which can be processed asynchronously. Okay, this is not what will tie, what will grab the main thread. We'd like to free. I like to instruct the system that, well, when you call it, you know that you will be getting your thread back, your control back. So for that, you have to make it async. Well, I'll do one thing. I'll just make a copy of it. I'll make a control KC on it. I'll paste it back and I'll keep on changing so that you can side by side compare both of the things. Now we are going to modify this code. The very first thing is that we have to make it async. Okay, and the very moment you have async, it is quite likely that you are awaiting on, see, just doing async won't make it do anything. If you have an async, if you mark a function as async, you may not be having an await keyword inside, but that is very unlikely because you have a function marked as async because the function does give back control at some point, right? So that is what it is. Async means the function will be processing to some extent. After that, the function will be leaving the control back to the caller. That is what is async means. So let me click on it and let me try to get the cursor here. You see, we don't get it until we get response, and also we do not see processing. Please wait. So just having async doesn't solve this. We have to identify the real bottleneck in here. The real bottleneck is lying here. This function is taking a whole lot of time. So why don't we make this function await? Fantastic. As we had an await keyword, the warning in green goes away. So that means this function can now be asynchronously called by the system. When you click the button, the system, the .NET framework, call this button click. The .NET framework is basically running in the main thread, and .NET framework will be happy to see an async function. So that means the framework will be given back control. The thread will be returning, we will be getting back the thread's context, and the main thread will be available for the UI so that the UI is free doing its own work. So you can type in the text boxes, you can drag around, you can maximize, minimize, you can do anything. Even you can click the button once again. Okay, but there is a point. There is a red squiggly. It's telling, hey, if I'm going to call this function must be giving me a task, must be asynchronous as well. So what it means is that if it is awaiting on a function, this function actually does the threading. So as I told you before starting this session, then you must be having some fundamental ideas of threading. So what it all says that this function must be an asynchronous function. So what we will do right now, we will try to make an asynchronous version of this. So let me copy this. Okay, let me get it down. Let me, so that you can have both of things in one place. You have to make this function an async. Just I named it async for now. Okay, you'll find in many places, in .NET Core applications and in many places, you'll find an async await, and it is awaiting on something async, right? So that means Microsoft has really supplied asynchronous version of the original functions. So that means you may both have the original function, also the async version of it. So that is how the Microsoft will be supplying its asynchronous version of all its original work. So now it is we who are learning how exactly to get to an async version of a usual simple task. So that was a simple task. We are trying to modify this to get an async version of it. So how do you do this? To do this, first of all, this async version will not return, please understand this point, will not return you an integer, rather is going to be returning a task. Please understand this point. There is a new class starting from .NET 4.0 known as parallel task library. So this function itself is not going to be returning the integer itself, because this function is going to be running in a thread and the function will be starting that thread. However, the function will be returning a context of the work. Now please understand this point. This function will be creating a workload. Let me write in lines. Create a work, also known as task. Okay, then start that work, return the work. Lovely, these three steps only. Okay, so you have to create a work, also known as task. So this is point number one, that you have to create a task, then you have to start that work, that is start that work means task, and you have to return the task. Now returning the task means just the task itself. You'll understand it better. See, the first thing and second thing and third thing are the only three things that you have to do over here. The very first thing is to create a task. Okay, to create a task we write task, and this task is something that is returning an integer. So you must have a task of integer. You may also have a void task, the task that returns nothing, but task is a generic one. So you must be having good concept of generics in C#. So generic task, I just give it a name task, and then equals to new task. Well, and within that we are going to create a workload, and doing this will be done using lambda expression. So the task will be nothing but to get everything that is here, cut it from here and shift it inside. Okay, So inside this async function, we have created, don't worry about that red squiggly, it is going to be getting away. So we have created the task, new task, and then we have copied the task body inside it. Copying the task body doesn't mean the task has been started. It is just a work piece, an execution scheme that has been assigned with this variable. Okay, this is just a work, like how to do something has been assigned with this task. Now you can start that task actually by calling it. You can write task.start. So here the task really gets started in a different thread. At this point, when you call it asynchronously, the main interesting point is that it really calls this function and it really creates this task, and whenever the time comes to start the task, it really starts this process in a different thread. This will actually execute the task in a separate thread. So from here the real spawning begins. Spawning means from one thread you spawn, you give birth to another task, to another work execution system, execution unit. So that basically spawns, and after that you will immediately return this task. Now since you are returning task and task of integer, you just need to write, okay, I am returning a task of integer and not just an integer. You can see that red squiggly got over. Okay, so no more there is a red squiggly, and that is the end of this work. It's very simple now. So what do you see? We can even have this. Okay, let's have it here itself. So first of all, we start writing please wait. So that executes in the main thread. Calling this function asynchronously also waits in the main thread. After a while, you are basically this task gets created internally, assigned to a variable task. You can let it to have any name, and you start the task and you immediately return the task. So while the task is still continuing in the background, you are returning that task to the caller, that see, this is the task which has been instantiated, this is the task which has been ordered and called. We are giving you an awaitable for that, so you can await on that task. So basically await means you are awaiting on the task. It just gives an awaitable, that means it just returns you the real task. You might be questioning me, hey, isn't this function returning a task of integer? But on this await, we are just getting this value back inside a number. This is not an task of integer. Well, this is a shortcut. This is a real shortcut. You could technically got this as well. Task of integer, just name it as something like task. Okay, it gives you a red squiggly because if you just call it right like that, you will get it that way. Okay, so you could have called it this way. You see, my long async function, then you get the task over here, and once after a while when the task is finishing, you can still write number equal to task dot result. Okay, let us see what is the outcome of it if we do like this. we'll run it. Click on it. You see, as I am trying to move the cursor inside, it did not move until the same thing. It is having the same problem. See, as I click on it, the same problem is there. As I click on it, though it says immediately please wait, but we are not able to move the window until the process starts. So the little advantage that okay, this please wait really comes up immediately because the work is being scheduled within a task, but this waiting is still being done on the main thread. So we get rid of that one by writing this shortcut syntax, and which is better. I definitely will tell you this is better for one reason, that this will not wait on the main thread. So this is what is the main thing. You are calling this function asynchronously. That means there is a point of suspension. We can call it point of suspension, that you are calling this one and now waiting until the result will come. But this wait has got nothing to do with grabbing the main thread, but you are still waiting. So that is the point of suspension. But very interestingly, this does not lock your main thread. You will not be able to proceed with any further codes that are down until this lock is released. This point of suspension is over. So whatever comes earlier will be done. After that, at this point of suspension, there will be a waiting, but it will be relinquishing the control back to the main thread. So main thread will be happily free to do its task. Then all of a sudden, when the response comes, then main thread, if not busy at the time, will be getting this thing and will be doing all the things that is down. Please understand, the very moment the task is over and you get a response over here, and at the time the main thread itself is busy, you will not be able to get these responses. So the main thread should be free. Okay, so let me get rid of these semicolons, which are just null statements, nothing else. So let me run it and show you the real outcome. Okay, now you're able to shift your window. Let's click on it and also try to shift. You see, wonderful. It does it, and also you can find the response coming over here. This is the true spirit and async, await and task processing work. So let me summarize you the things that you have done. If I click on it, you can also get the mouse cursor over here, you see, in case you are curious about it. Okay, so let me summarize. The first version of the program was simple. This is the first version. Okay, we had normal button click and we said please wait, which never turned on, and after that we called a task, called a function, and made that function return the value over here, and that function was processed in main thread, which really locked our main thread, and the main thread really got freezed, and nothing good can be done until the function returns. And after the function returns, we are ready for the response. We see the response and we could never see please wait. Okay, that was one problem. That was a problem. We got rid of that problem by making an async version of that event handler. Now, to have an async version of an event handler, you have to identify the long task. Which is the long task? Okay, that is the long task. That was the task. And you have to create another version of it. So that new version of it has got 3 important steps. First, you have to create a work, which is a kind of task. It's basically task. You have to be starting the task. You have to be returning the workload, the task itself. Creating the task has got a lambda expression inside, right? So you just have to be writing task of integer, signifying that this workload will be returning an integer, okay? Task of integer. We are doing nothing significant over here, just waiting for 3000 milliseconds, making the thread onto which this task is dependent to go sleep for 3000 milliseconds. Just make it sleep for 3000 milliseconds. Fine. It will be waiting, and after that we are spawning a random number, and this random numbers we are using the next function to get anything between 1 and 10. So that is the randomness, and that value is obtained inside this num and we are returning it. That is a small task, small function which we are basically wrapping inside the task object. Okay, so that is the main purpose of any delegate. You know, delegates is helpful to wrap up anything, any function. So basically this object wraps up this stuff and it gets us inside a function variable. Task. This task is basically that encapsulates a function, and then we are kicking start that task. This will actually start the task in a different thread. So threading was not enabled until you move to this point. Well, after that we are free to get back to the caller. We are just returning this task object. The very moment we are returning this task object, awaiting really begins. Okay, awaiting really begins, telling that okay, I am awaiting for the task to finish itself. It awaited, and when the task finished, it will be returning the actual value of the task, which is the integer right inside here, and we can happily display it. Okay, so pretty much these 3 lines of code in here can only be helpful if someone has created this function asynchronous version for you, and you'll find yourself not to be writing this task of integer or learning anything of this short. You'll just find yourself calling an async and await. Whenever you find this async and await, know one thing: this function is calling on something which can take a longer time, and you don't want your caller thread to be tied with your event, with your function, whatever this might be. This might be event function, this might be any ordinary function, this might be anything. Okay, so that means an async and await keywords just makes caller happy. So who is happy here? Dotted framework is happy here. Okay, the dotted framework is happy here because dotted framework is calling this button click. Dotted framework knows okay, this is asynchronous, so that means the framework understands that the thread which is responsible to calling this, the thread will be free very soon. Okay, that's it, very simple. I hope I just made a little longer session for this async and await to make this concept little bit clear. I know there are a lot of different audiences listening to this. Many people do not know programming at all but still interested to hear this. There are a few, someone who knows to some extent C#, lambda expressions. they'll find this little bit better, but a little concept of threading will be fantastic to understand and appreciate this concept. However, if someone don't know anything, just know one simple thing, that having async and await just makes the caller very happy, because caller knows that the function whoever it is calling will be relinquishing, will be releasing the thread very soon. It will not tie that up. It will not let the thread tied up with its own task. That's it. Dear viewers, have a fantastic day ahead and take care. Bye bye.